Hello. Today we are going to discuss quadratic equations. A quadratic equation is a second-degree polynomial equation in a single variable. This where a does not equal 0, because when a equals 0, we have a constant function. So if a equals 0, then you have just a line, a linear equation. But when a is not 0, we have a quadratic equation. And so a quadratic equation has this typical U-shaped curve, which is called a parabola. And the parabola can open upward like this, or it can open downward like this. Here you see a quadratic equation in standard form. ax squared plus bx plus c. This quadratic equation, where it crosses the graph of the quadratic equation, the x-axis is where the roots are. The roots are the solution to the quadratic equation. Now, the equation could cross in two spots. It could cross in 0 areas, or it can touch the x-axis, and so it will have one root called a double root, and that looks something like this. So again, in standard form, the quadratic equation is ax squared plus bx plus c, where a is the coefficient on the x squared term, b is the coefficient on the x term, and c is the constant. By changing a, b, and c, the graph of the quadratic equation changes. So let's take a look at what happens when we change a. So a controls whether the parabola opens upward or downward. So if a is positive, it opens up. If a is negative, the parabola opens down. And again, if a is 0, then you don't have a quadratic function, you have a linear line. Let's look at c. So I'm going to set my a here. Let's set it to 2. And let's change c and see what happens. So c controls the y-intercept. So if c is 2.5, the graph crosses the y-axis at 2.5. If c is negative, then it crosses the y-axis at a negative number. So c controls that. B plays a role in the vertex. So as I move B, you can see the parabola moving, and it plays a role in the vertex. Now the vertex of any parabola is the highest or lowest point of the parabola. So in this parabola here, if your parabola opens upward, B is the minimum point. If your parabola opens downward, then B is the maximum point. And so the equation to find the vertex, the formula to find the vertex of any parabola, is the opposite of B divided by 2a. And that will tell us the x-coordinate. To find the y-coordinate, you'll take that value you find for the x-coordinate, plug it into the equation, and get an output, and that will be the y-coordinate. That's one way to find the vertex. The other thing about the vertex is that the axis of symmetry always falls to the vertex. So if I click here, I now created the axis of symmetry. The axis of symmetry is a vertical line that goes through the vertex of a parabola. And that vertical line forms a place where the parabola could be folded in half and forms a mirror image with the other side. So it's symmetrical about the axis of symmetry. And so as I move these are A, B, and C, you can see that axis of symmetry move also and change. And so if I click this, my axis of symmetry line will go away. The domain of any parabola is all real numbers. So to find the domain, I look at the x-axis here, and I can see that if I looked at this graph from further away, I would see that I could pick any x value to plug in here, and I'll get an output. Where the range depends on the vertex. So the range will only be from the vertex to infinity if the parabola opens up. If the parabola opens downward, the range would be from negative infinity to the vertex. So the y values. If we want to find where the parabola crosses the x-axis, we would set the parabola, the quadratic equation, equal to 0. When we set it equal to 0, we can solve for our x. And so we can solve different ways. We can factor, we can complete the square, or we can use the quadratic formula. If we choose to use the quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. Now the radicand is the part under the radical sign. That's b squared minus 4ac. That part of the quadratic formula is called the discriminant. The discriminant will tell me whether I have two real roots, one double root, or complex roots. And so if we just plug in b squared minus 4ac and we get a positive number, then we'll have two real roots. If that positive number is a perfect square, we will have two real rational roots. If it is not a perfect square, we'll have two irrational roots. If the discriminant is equal to 0, then we're going to have one double root. And so our graph is going to just touch the x-axis. So something like this. If our discriminant has a negative value, if you have a negative value under a radical side, you can't take the square root of it. So that means we'll have a complex number. And the graph of the parabola, if it is a complex number, will look like this. So it will not cross the x-axis. There is no real solution. So either will look like this, or if our a is positive, it would be somewhere up there. It will not cross. That's our brief lecture on quadratic equations. Thank you.